So we're looking at the quotient rule today. We've talked about sum difference rule, power rule, constant rule, product rule. We're looking at the quotient rule now. And the quotient rule dictates how we find the derivative of a function that is comprised of two polynomial functions that are divided. So quotient is the solution you get when you divide. So what's the rule when we're talking about a division of polynomials? So we're going to try and prove this. And the way we're going to do this is we want to find capital F prime of x, right? But we don't want to show it as a quotient. We want to show it as a product. So what if we did this? F of x, right, equals F prime of x times g of x. Are you with me there? So we can just rearrange this. Now, if we took the derivative of F prime of x, right? Sorry, not the derivative here. That shouldn't be there yet. This is just like this. So if I took the derivative of this, then I could use the product rule here, right? And I would end up with, in my expression, I'd end up with a derivative of the capital F of x. And I'm not sure why they didn't just use a different letter in the alphabet, but whatever. So this is the one we're trying to find the derivative here. So the product rule says the derivative of the first times the second, and you add to that the first times the derivative of the second. All right? So that's g prime of x. All right? So that's all good and well. I think what we need now is to solve for this one, right? If we can. So we'll solve for that one. So let's see. Let's isolate this. So let's go f prime of x minus capital F of x times g prime of x. Right? We're getting rid of this from one side. And we're going to divide by g of x to get this. You with me so far? Mm-hmm. So we're solving for f prime of x. This is what we're trying to find, right? Right here. We're solving for this. Now the problem is that we have we want this only in terms of f and g, right? So right now I have capital F of x. So I'm really, really close. What is this equal to? Well, we know that capital F of x is equal to f of x over g of x. So now let's substitute back in. So I've got this, and I've actually got f of x over g of x here times g prime of x. Okay. So that's still looking a little ugly, but this is equaling our our derivative of the capital F of x, which we're looking for. So let's simplify this a little bit because this is not quite usable yet. But if I did this, if I did g of x over here over g of x, like this, now you see that you have this term divided by g of x, this divided by g of x, all divided by g of x. So this g of x here, you could think of it, well, let's do common denominator. So we'd actually have g of x times f prime of x minus f of x times g prime of x all over g of x all over g of x. So we're getting really, really close. We're getting really, really close. And what we want to do here now is if we divide by two things, we divide by something and then divide by something, it's like we're dividing by the product of those two things. So we end up with this. All over g of x all squared. Okay? And I like to do one thing. We're pretty much done there now, but I like to do one thing. Remember I said yesterday, I always like to start with the derivative of the first or the derivative of the top. So I'm going to rearrange this to be the derivative of the top times the bottom function minus the top function times the derivative of the bottom function. So in this way, it's very similar to the product rule. All over the bottom function squared. And that is your quotient rule. That is your quotient rule. So we're just in terms of f and g and f prime and g prime. That is the quotient rule, and that is the proof.